Hello, welcome to the Banauliwood Film City, and I am Einstein from Germany. And today I am going to discuss about the special theory of relativity. So let's see the discussion all about the special theory of relativity by Einstein. In this discussion, first we would like to discuss about Michelson-Morley experiment and its interpretation through which negative results were obtained. So let's discuss the Michelson-Morley experiment. According to the Webb theory of light, a light source created disturbance traveling in all directions through a hypothetical medium which is known as ether, and it fills all space and penetrates through all matter. The assumption of ether, however, created a problem. Does ether remain stationary in space when material bodies, including Earth, move in it, or is it dragged along with the moving bodies? First, Bradley observation of the aberration of light from stars and had indicated that the ether must be stationary in space. It means that if a material body, say Earth, moves in space, there is a relative motion between the ether and the body. A number of experiments were performed to detect a relative motion between the Earth and the ether. The most famous among these are one performed by Michelson and Morley in 1887 using the Michelson-Morley interferometer. A simplified plan of the experiment is shown in the figure. A beam of light from a source S falls upon a half-silvered glass plate P placed at 45 degrees to the beam and is divided into two beams, beams 1 and beams 2. These beams 1 and 2 traveling at right angles to each other all fall normally on mirror M1 and M2, which reflects them back to P. The two beams return to P are directed towards a telescope T in which interference fringes were observed. Consider the mirror M1 and M2 be at the same distance L from the plate P. Then if the apparatus were at rest in ether, the two beams would take the same time to return to P. But actually the Earth and the apparatus are moving in space through the ether with a velocity v. Consider and suppose this motion is in the direction of the initial beam of light. Then if the initial beam strikes the plate, then if the initial beam strikes the plate P in the motion shown, the path of the two beams and the position of their reflection from the mirrors will be given. The time taken by the two beams on their journeys are not equal. Consider c be the velocity of light through the ether. The beam 2 moving towards mirror M2 has a velocity c minus v relative to the apparatus on the outgoing trip and is velocity c plus v on the return trip. If t2 be the total time taken by this beam to go from P to M2 and back, then we can write T2 equals to L by C minus V plus L by C plus V equals to 2LC divided by C square minus V square equals to 2L by C open bracket 1 by 1 minus V square by C square close bracket. This will be equation 1. The beam 1 moving towards